welcome to another Random Code stream. This is part 2 of writing an analyzer and a code fix to help a developer put those little digit separators, the underscores, in in literals, so numeric literals. So let's move on, get the music going. So we got something in the background. All right. This has turned out to be more complicated than I thought. It's not super complicated, but definitely complicated. You'll notice that. Wait, let me get my things up here. So you can have prefixes, which we already know, the 0x or the 0b. You can also have a suffix. So if you don't have one, or it could be a U, or it could be an L, or it could be a UL. So we got to worry about that at the end. You can also have negative numbers. So you can do something like this, and that's perfectly legal. Okay, that says that it doesn't put the value there, but that's perfectly legal. It's complaining because we're not using it, but that's fine. So there's some complexity here, and we got to be a little bit careful. We also see that there can be a dot, right? Because you can have like double D is equal to 3.4. You can also have it being 34. You can also have it being this. And those are all fine. Again, they're not being used, so it's complaining about that. But you can assign doubles as integer values, and then they'll just be put in as a double. You can also make it a B, which of course that doesn't work. You could do that, and I think you can also put a negative in front of it, which is fine. You won't have any suffixes with these, though. Well, you can if you look at the floating point ones. The type of a real literal is determined by its suffix. So as it shows, you can put the digit separators in here if you so desire. And then there's also exponents. So I believe you could do e to the 5. No, that doesn't work. It doesn't like that. Now it's just saying put a var there. We could do F, and now it's a float. Yep. So these literals are getting to be quite fun. Yeah. We do 2. And that's fine. But we want to actually put it there. So we do need to be worried about e to the 2. Or just using e. Hey, Craig. So, yeah, this is all like that. Like the details that I honestly don't run into on a day-to-day basis. And yet, if we're going to want to make sure that we're reporting this for numbers that really do need it, that we do want to suggest you add a digit separator to, we've got to parse this text, the literal text, correctly. So that's fun. And as you can see when I was typing those values in, that there's already code out there that at least tells you if you've put in the right or wrong values and things like that. It's probably buried somewhere in the Roslyn code base, or it's maybe something within Visual Studio itself. I don't know. But I'm guessing it's not something that's readily available. So the way that we're parsing these numbers, we've got to be really, really careful with. We also want to know what happens if, what if I did that? What happens if I had just an error within the format? Like I did 1000121. You see, there's code in here that tells you these are not very helpful errors, but it knows that there's something wrong with this. Because you're supposed to have, for a binary literal, you can only have zeros and ones in it. And the problem is that this... No, go away. Is that it doesn't contain diagnostics in and of itself. The diagnostics are up on the local declaration statement. So that's a little unfortunate because like it seems as soon as it finds an invalid thing in it, it pushes it to the declaration. So how far up the chain do you go to say, we don't want to do anything with this number, this numeric literal expression, if there is an error associated with it? Like you can see, this contains diagnostics, but not the literal expression itself, which kind of sucks, you know. Because how far up the chain do you go? Like the whole compilation unit has diagnostics. But how far do you keep going up to going, oh yes, this is something where a numeric literal could be part of as a statement? Because I could have something like static void foo int x. And I could do foo of 3. Okay. And now if I look at 3, that is a numeric literal expression as well. But are we going to start to go all the way up with like all the places you could put numeric literal expressions and determine whether they're actually correctly formatted or not? Because that's what I would want to do. Before I do any of this, I would love to know, is this actually considered like a local declaration statement syntax? What does that derive from? No, I just turned up the volume. That's not what I meant to do. It's a statement syntax. Okay, so that's a statement syntax. What about a... so local... Okay. Yeah, type the example I just made before static void. This may seem very boring, and I get if it is, but this is the importance this is why it's important to know a lot of the details around where things are. This is a 3. Okay. So let's put this whole thing in here. Now, I could do that, and that would be fine. Okay. But now I've put this in here. The numeric now is part of an argument list, which would be, it's also part of an expression statement syntax. Oh, great. Would be nice. Why is it a partial? I mean, it's the same file. But it doesn't help in terms of trying to determine Jeez, that's bright. Use member name. And I know I feel like I'm kind of barking up the wrong tree here. I really would want to know though if there are any I was about to say, oh, it could be within a block, but you don't necessarily have a block because you could have top level statements and those aren't in blocks. I mean, at some point, you're going to be within a class, you're going to be within a method, but you can have top-level programs. And I think, do I have .NET? Yeah, I do. Like here, if I look at the syntax, this is not within a block. Which is fine. So the point of, first of all, what I'm trying to get is I want to see if I can find a way to say if this is declared in such a way that it's causing a diagnostic, then don't even do the analyzer. There's other things that are wrong with it that need to be fixed. Right? But you could have something done in the method declaration that's wrong. That has nothing to do with this value. And so we would want to say, provide the refactoring. Or, I'm sorry. Suggest the analyzer and offer a code fix. So like this whole thing is an expression statement and it's part of an argument list. We could say if you put the... I'm just trying to figure out where can you make a numeric literal expression show up such that there's a consistent way to determine if a parent node has a diagnostic, because it's not going to show up. It's not showing up on the numeric literal expression. Here it'd be showing up on the argument list, not even the argument itself, because the argument it thinks is this. Once it sees the 2 here, it's going, well, the 2 is not a part of a binary, if you're using the binary format. So it stops and it says, well, this is the numeric part of it. The rest of this is wait. Oh, there's 2 arguments. So it thinks there's 2 arguments here. Okay. So, and this is also a numeric. Really? But neither one of these have diagnostics. It's something above it that has it. So it's a little... This is getting pretty messy to try and figure out how do you know if if the number that's put in there is even correct? Because in this case, we're going to get 2 of them. You notice that? We're going to get both this and this. I'm guessing maybe what we can do is say, just keep going up the parents, and if any of them have, excuse me, until you get to the compilation unit. Now that kind of sucks because again, you could have a class that has multiple methods like this one, where if you were in the, if you were in that declaration, I guess maybe, let me try that. What does that derive from? Really? Ugh. I'm frustrated because I want to know what these things derive from. And they're all in these stupid partial classes, which does not help. Source .net. Type declaration syntax. What do you derive from? I don't know if they've always done this. Sorry, I know I'm getting sidetracked here, but this is important because if I can't even figure out what these classes derive from. Yeah, and this is all the references to it, but that doesn't help. This has suddenly become a problem. And not... It's a problem that if you have a partial class, and I do F12 go to definition there, how do I know what it's actually deriving from? I know that type declaration syntax has to derive from something else. I don't know what it is. This is a type, right? It's a class. What does class declaration syntax derive from? A partial class. But I bet it derives from type declaration syntax. What happened with this? This isn't very helpful at all. Like, how in the world would you ever figure out what a type derives from if it's a partial and it's declared multiple places? Or maybe it's even source generated. But then the source generated part may or not be part of the source code. And so how would you know what... And I'm not saying that's what they do, but man, that kind of sucks. And again, the reason why I'm trying to do this is find stopping points when I go up the parent tree to say, well, excuse me, one would be a block. That would be simple-ish. God, I can't even talk right now. I'm so kerfuffled. That would be, if I click on one of these, the syntax visualizer is going to go away. But if I click on the block, that could be anything within this block that's doing it, and not just the expression statement. What I really want to do is have a function that says, go up the tree as soon as you hit one of these types, and it has diagnostics. Don't offer up the analyzer. And if I can have stopping points rather quickly up the tree, that will help tremendously. Like, you could have method declarations, you could have field declarations, you could have, but all these declarations I thought derive from like a field declaration syntax. Base field declaration syntax. Member declaration syntax. I think that's the one that all of these derive from. So if I go back to my notes here, actually I gotta move my screen down here. So I'm not even writing code, but yeah, I've got to figure this out, because I need to have some kind of heuristics to say this is an error. And it will not be on the literal expression itself. It just won't. But what it would be on is something like an argument list. It won't even be on the argument. You notice that? I think that's just syntax. Here. that would also local declarations syntax, local declaration statement. Yeah, God, I hate it when it does that. The syntax visualizer. A field would be in a member. So what happens if we have private const int is equal to 3? Int QQ. There we go. This is a numeric literal. And the field so it's considering it considers all this to be a field. So that would be a member declaration. And if this was 0B12, the field declaration would eventually catch it. Now, if we go all the way up to the compilation unit, we can stop because it could be an error, but it's not something that's an error of what we are up on the parents that we're looking for to make it quick. So yeah, and it's interesting. Then in a case like this, you're actually going to get two arguments, which is not correct. Well, I mean, the tree is correct. It's just not. You're getting something that is not what you expect. We could stop. Did I put argument list in there already? Yeah, I did. Okay. Local declaration already got. So declaration, an argument, a const. If it was a read-only or just a field, a property being set to an initial value would be a member declaration, I bet. So all of that would roll up. So if you're kind of wondering what I've been babbling about for the last 30 minutes, is I want to write a function that says, here is a node. Okay, this is a syntax node. Literal expression. They all derive from the nodes all derive from syntax node. So I want to say, here's the node, and if you look at literal, there should be a parent. Yeah. And I want to just keep walking up the parents until there is no more parent. And say at each parent, because I know a literal expression will not have a diagnostic. So start walking up the parents and saying, if this parent's node type, this parent's type is assignable to one of these, and it contains diagnostics, stop. Now this is again, it's a heuristic. We don't know. We don't know if it is actually on that one or not. But we want to try to stop it as soon as possible. And the ones that I found here, I think, will do it as quickly as it can. So, let's get rid of these. And what we want is an extension on a literal expression syntax. We want to be very clear here. That this is only intended for internal does I want to say may contain diagnostics. This literal expression self. This is a heuristic. A literal expression syntax will not have diagnostics on itself, but the parent will. This list should hopefully associate any diagnostics that exist with the literal on a parent node. That doesn't make any sense, but again, if we come back here and we look at this, do a 1 and a 2 there. And a local declaration statement. What's funny is that the local declaration statement here, this is an expression statement because that's how I was trying to interpret it as, and then it goes up to a numeric literal expression. So like this numerical literal expression will be part of a local declaration. It's weird because the part that's in error, even that doesn't have it. If you look at the expression statement, that's what it's determined to be. That's how it's parsed it out. But the part here, that's in a local declaration. So we're going to actually get 2 numeric literal expressions here. And the one that's technically not in error, the one that you consider to be part of, excuse me, the right part is actually part of the wrong part. But again, we're not going to report errors. We're just saying we only want to parse the text within a numeric literal expression if it doesn't have any errors. And the only way to determine it is by looking at parents to say, parents that are close enough to go, yeah, this is probably in error. And so we're just not going to evaluate it. And so the user is going to see something here and go, oh, wait a minute, this is not even correct code. This is diagnostic. So let me fix this. And now we're going to have a numeric literal expression that will be clean. And we can actually now provide our refactoring. So that's, I think, good enough. Okay. So what we want to do here is we're not going to look at the literal expression self. We're going to var parent is equal to self parent. What we want to do here is say var contains and then we're going to return make date doc. Okay. So we're going to say while parent is not null. And then we're going to say parent is equal to parent parent. Okay. Now we want to say if parent is a local declarations or parent is this literally is. That's the problem here too. I got to be a little careful about here. I think you can do this. So we'll have these, and we'll say if it's one of those and parent contains diagnostics, we say we can say, yeah, we can actually just say here return true. And then here we'll say return false. We can get rid of this. I think that's good enough. We will definitely want to have tests around this method. Okay. If not, let's not even do this. If not literal may contain diagnostics. Grab that. There. So now I can get rid of all these because I'm capturing them there. What are you complaining about? Oh, that. Okay. So now if I go here, these should all still pass. And they do. What we also want, and I gotta watch my time here, because I do have a stand-up pretty soon in the morning. What I also want to do is have tests around this. And I want to catch all the cases that I think I'll find this in. So let's put a folder in, extensions, put a test in. How do I want to do this? I want to have a block of code. Test. No, not that. Public static void. Hey Mitch, yeah, thank you on 1K subs. Yeah, I did finally get to 1,000. I've been a little quiet about it because I'll say more about this when I do my Hollow Knight stream tonight, but I've been a little bit quiet about it because I can just see some people trolling me and just unsubscribing, so I don't get it. So I'm trying to continue to get past that and just be like, hey, thank you. But yes, I did hit that yesterday. No, Monday. No, yesterday was Monday for me. Whatever. Sunday, I believe. Was it Sunday? No, maybe it was yesterday that I noticed I finally got to 1K. So that was nice. So now I can actually start doing that little bit of ad revenue, or I have to get my account verified and stuff like that. But I could move through on that process now. So that's just going to take some time to have that roll forward. And if you are watching and you haven't subscribed to the channel just yet, please do so. I'm going to keep saying that because the more subscribers, the better. And I do appreciate it when people subscribe. It helps grow the channel. But anyway, thanks, Mitch. I appreciate it. So I'm trying to think of how I want to write this test. Because I could do test cases and give it examples of code to run into some cases and say, should any of the literals have any, and I have to say literals because like you just saw, I could have a literal that is an error, and then the parser is going to put that as two numeric literal expression syntaxes. So I have to be a little bit careful here in that I want to find all of them and say if any of them have it's weird how the tree is parsing this. At least it looks weird to me. I'm sure somebody on the Roslyn team could explain exactly why they did it the way they did it, and why don't I understand that, and it should make perfect sense. But I'm like, it just doesn't make sense to me at first glance. But whatever, I didn't write that code. So so what I want to do is almost have like a test case, say here's some code, parse it, find all the literal expression syntax nodes, and determine if any of them are in error. The thing though with doing that as a test case is contains diagnostics. So string code bool should, like this. Okay. And then I could put in code here as a test case. Okay. Where actually, I think if you didn't put in a class, it would almost assume it to be a top-level statement piece of code. I wonder if that's how it does it now these days. But I want to have something like a public static class test. Public static void do and let's say this one shouldn't fail. So now I have a test case here that's going to be a bunch of code, but you can see how it's going to start making all these test cases rather big. But it also potentially makes it so that I don't have to have multiple methods here, but that might actually read better. I'm actually not going to do this. Is correct. I might have a helper method to do this. So I can say like var code is equal to back it up. Back up the bus. Let's grab this. Forward the bus. Okay. By the way, Mitch, if you're still there, I'm blaming you for all this. Because you started getting me to think about how literals can be expressed, how they can be stated and defined, and it's led me down a rabbit hole. So, yeah, thanks. But correct, it's the right thing to do. So, and now we'd want here to have like a private static void contains and so here we say string code and here we say bool and then here we So here we'd have var x is equal to 1, 2, 3. That should be perfectly fine. And then we would do this. Okay, and then in here, what we're going to do is syntax parser. No, what the? Syntax factory. And then we get a var unit. And we want to get var literal. We want to get all the literals on it. Unit. Descendant nodes. Where we do this of type literal expression syntax. So what would this be? This would be an enumerable. No, don't apologize. It's not your fault. I'm going to blame you, but it's not your fault. So now what we want to do here is say for each var literal and literals, assert that literal may contain diagnostics is equal to may contain diagnostics. And so in this case, this should come back as correct because this should not have any, and it doesn't. Okay. So now let's do like public const int is equal to 0b 1 0 0 1 2 1. This should now be true. And it is. Because it's detecting, it's going to find this, and then it should also find this. And both of those are part of a member declaration. What I'm curious about is where did it find it? So let's put the breakpoint here. And let's see where it found it. So what is parent? It's a field declaration, which is a member declaration. Perfect. So again, it's a heuristic, but it works. We're going to say, nope. Now, here's the thing, too. We're finding two of them, here and here. Right? If I come back to this, I'm going to see this get invoked twice. That's the first one. And it returns true. Oh, no, it only did one? Really? I thought that would do two. That's what it was showing in the... Yeah, there's the 0B1001. Wait, does this actually, if I put this here? Oh. If I look at the visualizer here, there is a numeric little expression, but what's this? That's interesting. In this case, the numeric literal expression. So maybe I should check that first and just say, hey, if the literal expression syntax actually has it, then just stop. Where is this, though? Huh. This is considered to be trivia. This is funny. But this does contain diagnostics. It would go up to the field declaration and realize something's wrong with it. But let's put that in there just to it's mostly for short circuiting. If self contains diagnostics, turn true. Just get out, just bail out as fast as you can. Because in that, like you saw in that case, the 2-1 was considered to be, if I do like that, now I go into the syntax visualizer, I come into here. Let's get it to show up again. Now we have a numeric literal expression there. What is the 2 here? It is also a numeric literal expression, but it is part of, in this case, we should see 2 if we did it that way. So if I have a test here now that says, this should be a variable. And so we'd want to have something like public static void do or X is that. That should be an error. But in this case, this is where we should see 2. Whoops. Sorry, I got bad stuff. And it passes. But it should pass because we hit it twice. Yeah, see, we're hitting it twice because it finds 2 literal expression syntaxes. Wait, why did it? Oh, because it goes up and it probably finds that it's part of the local declaration syntax. Okay. Which wouldn't be a compiler anyway for bind? Yeah, it would be. It is. I mean, this won't compile. That's why when I put it into, like if I take this out and put it here, that's now a compilation error. And that's why you'll start to see things down here. It's a little bit hard to see. But it's not saying like literal expression is invalid. It's saying a semicolon is expected because this starts getting all messed up with other things. It's parsing this out as 2 literal expressions. This and this. And the second one is just, it's considering to be incorrect, and then it gets the semi, and it does other things. So at the end of the day, yes, it will stop your compilation. If you actually tried to compile it, it will just say, nope, this is invalid code. You'll go there and you'll start to look at it and go, oh, okay, maybe the error isn't extremely helpful, but it will still stop the compilation. So, but the point is, the problem though becomes, no, it doesn't, because in both cases, both this one here and this one here are both part of a local declaration. As weird as that seems. So you can see all of this. Well, no, it's just that. This is actually not part of the local declaration statement, but it's part of a block. So both of them would get caught as being something in error. And hopefully something in error that is close to where it's being declared. The problem with it catching it in the block is that this could be fine. The declaration statement could be fine. But the I wonder if you can no, that wouldn't work. I was wondering if you could do a text span to say, is the literal that I'm in is a part of the thing that's in error, because again, it goes up to the block, but the block itself might have something wrong with it that's not related to what you're doing. But again, I have to keep reminding myself, this is a heuristic. We're just trying to bail out of providing you an answer or a suggestion until your code is in good enough shape. So you could, for example, do this. Okay, now it's, again, there's a line here, but that's just a, it's being assigned but not used. Okay, but now I could say, take the semicolon off here. Okay, this local declaration, this literal expression is fine, but you'll notice that that literal expression is part of a block now that is an error, but we're going to catch in the local declaration statement first that it's okay. If you look at this, it's actually going to be okay. So this is actually another thing that might be interesting, is to say, even in the case where you have like the block is an error, like if I took this off, this is still fine, but the block that it's contained within is not anymore. So what I would expect now to see is if I did this, okay, that's incorrect. When literal is correct and within incorrect code. So what I'm trying to say here is, now if I did this and I just so happen to take the parentheses off, this should still come out as false. Oh, it failed. Well, that sucks. What did it hit? The parent is a class declaration. Okay. Maybe I didn't... And again, this is a little dicey to... Not the Server Explorer. The text visualizer. That yes, if you look here, it should have hit the block though. You'll see the block doesn't actually have the class declaration is what's the problem, but the block itself is fine. Oh, wait a minute. Oh, this is going to be tricky. Maybe. I am hitting the block, but I am seeing that it does not contain diagnostics, so I just keep going. I should say if I hit one of these, that's where I bail out. Okay. What I should actually say here is this. If it's not one of these, keep going up. Now, if I come to here, and let's get rid of this bad code, this code that's bad should now not have a diagnostic, and that's true. The rest of these tests are all fine too. Okay, so I feel like I've got at least a decent-ish heuristic to determine if I should actually do any analysis on this. No, that's not the thing I wanted to do. This is the thing I wanted to do. All these tests should still pass. And they do. So what I could do is have something in here just to, I like that I separated this out a little bit. I could put in the analyzer a test to say, by the way, if you have invalid code, you shouldn't even see a diagnostic. Even if the code is with no separator and diagnostics exist. So what I'm saying is if I did 0B 1001 1021, this should have no diagnostics. Oh. Well, okay. It does. It's true. It does, but it's not the diagnostic that I'm looking for. So let's actually grab that. I think we just want to say var diagnostic is equal to that, and then pass that in there. And now that should work. Right. So we are getting a diagnostic, but we are not getting a diagnostic that is our detect non-separated digits ID. This diagnostic is a compilation error, not our analyzer diagnostic. That is note for future Jason or anybody else that reads this code. All right, cool. Git commit added extension heuristic to not analyze potentially invalid literal expressions. There might be a better way to do this, but I'm going to go with this for now. So that was an hour of correctness. We're trying to. I didn't even get to the code fix. That's why I think I said in the title of this stream, or in the description of this stream, is that I'm going down a rabbit hole. But as I mentioned in the previous stream, that's what happens when you do stuff with Rosalind. You just start getting into rabbit holes and writing things that are correct. You see this, not a lot, but you'll see this when you use some of the analyzers that are within Roslyn or .NET itself, that sometimes you're like, hey, this isn't quite working the way I thought it should. And occasionally you'll find a bug because even the people on the team didn't quite think of all the cases. And, you know, what they're trying to do is release an analyzer that should hopefully catch cases that are valid cases. But if one is a valid case that fell off the radar, that's arguably okay-ish. Obviously, you want to fix it, but they're time constrained. I just found out yesterday, somebody mentioned on the Microsoft team that there's literally nobody that owns, or I don't want to say owns, but basically said there's no one that's working on IntelliSense right now. Which you could say, okay. I mean, the way IntelliSense works, IntelliSense has been around for decades, literally. So that should be pretty bulletproof and rock solid. But Microsoft just went through a round of layoffs, you know, and they may just not have anybody that's with all of their things that they need to work on. Just may not have somebody that's on that team or handles that part right now because other things take precedence. You know, I'm sure if somebody found a bug with IntelliSense, there would be people that would work on that, but there's nobody actually working on doing any improvements on it. But then again, do you really need any? You know what I mean? So that was a roundabout way to say, I can understand where they might release an analyzer where you're trying to catch cases that should help the majority of cases and help developers, and maybe you miss some, but you're not trying to say, here's a case that isn't a case. That would be bad. You don't want to, false positives are bad. You know, what would be the opposite? True negatives? I don't know, but you don't want to report something that actually isn't a case, because that ends up being noise. If you don't know it exists, fine, but you know, you may just run into it and go, hey, wait a minute, this is a valid case. So you read the two, very surprising that. Yeah. But again, you know, companies that are tens of thousands of people is not infinite. You know, and I'm not harping on you, Mitch, but I'm just, in general, I've sometimes heard people say like Microsoft or Google or Meta or, you know, or any of these, Apple or any of these large companies. It's like, oh, they got billions of dollars. Why can't they just do everything? It's like, because they can't. Nobody can. You know, we're a planet with finite resources. We can't literally do infinite everything. So there is criteria to go, well, how do we allocate? How do we, you know, figure out what's more important than something else? And sometimes you have to make decisions that may go, wow, that's actually interesting, but that's just the way it is. So, all right, I think I'm going to stop here because I do need to get my computer real quick and do some stuff. So I will be doing another Random Code stream probably on Thursday morning, I'm guessing, and then Sunday morning. So hopefully I can get to the point where I can actually start writing the code fix, because that's where I actually need to start. I need to parse it here, but then I need to parse it in the analyzer, kind of like what I'm doing here, but be a little bit more careful about negative numbers, having the things on the end to say what the type of it is. But then when I actually recommend code fixes and putting the separators in, I've got to be very careful about where I'm actually trying to put those separators in based on what the text is. So we'll see how far I get next time. Again, anybody who's watching who hasn't subscribed to the channel just yet, please do so. Would greatly appreciate it. I did hit 1,000, so my next goal is, I don't know, 2,000, and then 5, and then 10. Maybe I should make it 1024 and do it powers of 2, but any new subscription helps. And for those who have subscribed, thank you again for doing that. I really do appreciate it. I will be doing a Hollow Knight gaming stream tonight and Friday night as well. Schedule changes. And so with that, I am going to end the stream. Thank you all for watching. Take care, and I hope to see you in the future.